called positive lightning. The role of positive lightning in air accidents would never have won official recognition if plane crash investigator Peter Claydon hadn't seen his friend struck by lightning. The drama began at the London Gliding Club.
That day looked reasonable. It started off a little bit of low cloud and then it cleared to a nice blue sunny April day, and it was a nice day for flying.
We took the glider out of the hangar here. We then towed it over to the launch point.
I wasn't aware Peter was flying because there were a lot of people flying that day.
I didn't take any particular notice of the dark cloud.
That whole section of sky was black, evil-looking black, and it was slowly encroaching upon the airfield.
And that's when things went wrong.
Well, I'd landed and taxied in and was keeping an eye on the sky, as pilots generally do, and suddenly there was this very bright streak of light diagonally across the sky.
The force of the explosion had burst both of my eardrums.
I was aware of what was obviously a glider, descending nose down, rotating as it did so.
I do remember all my clothes fluttering wildly. I remember pulling the ripcord, and I then remember being surrounded with, like autumn leaves, all the little bits of glider that were all fluttering to the ground.
Peter Claydon realised that if his plane had been hit, he would have been killed. He'd not been wearing a parachute.
Had I been struck by lightning, then almost certainly I wouldn't be standing here now.
The crash was a mystery. Gliders had been struck before and survived. Peter Claydon wanted to know why this bolt was so devastating.
I thought this might actually be a very good opportunity to look at the subject of lightning, and we discussed ways in which we may be able to quantify the level of energy in the strike by test work at their laboratories.
The laboratory could simulate ordinary lightning, but the damage to this glider was very much out of the ordinary.
This actually came from the glider which was struck, and it hasn't actually melted. What you can see is simply the magnetic forces which have crushed the pipe down, and it is indicative of the fact that it was a very severe strike which took this glider.
To simulate the lightning strike, we actually use an impulse generator which can generate over 1 million volts.
The lab found their machines were too weak to replicate the immense force that destroyed the glider. Their finding had ominous implications.
And putting all the figures together, it was concluded by everybody who worked on this that it could have been as much as 6 times the present level to which aircraft are designed to tolerate with minimal damage. 6 times.
Though it looks like a normal bolt, this positive lightning can burn 10 times as long and unleash 6 times the power of ordinary negative strikes. The killer lightning travelled with an even bigger accomplice.
We were able to take pictures of sprites above storms while we were able to map the lightning going on inside of the storm. We've never been able to do this before. Went back and got the raw lightning data, and for every sprite, there was a positive lightning.
Positive lightning and sprites were one continuous force that stretched from the edge of space to where ordinary planes fly. Regulators had set airline safety thresholds for lightning before the discovery of sprites. The world's airlines fly with shielding to withstand only 1/6 of the awesome power inflicted by the positive lightning fired below the sprites.
We're learning there's a whole subclass of extremely energetic positive cloud-to-ground lightning that lowers maybe 10 times more current to ground than the old textbook said you should get.
There was potential salvation.
We're able now to actually use the sprite as sort of like the coal miner's canary, because when you see a sprite up there, that means there is an exceptionally unusual lightning discharge in the cloud below.
The sprites themselves might be used as neon signs warning of the positive lightning below. Positive lightning was deadly, and the sprites above struck an area 1,000 times bigger. Could they hit rockets? NASA funded the first sprite hunt in 1993 to find out.
So NASA was worried that many of the spacecraft, like the shuttle, weren't designed to take lightning discharges. And so if the shuttle was flying through sprites, what would the possible effect be on the shuttle or any other spacecraft?
In 1996, Walt Lyons reported to NASA on the dangers of sprites. He concluded that their vast size spread out their energy, making them unlikely killers, but cautioned not enough was known to be certain they were harmless.
We concluded that the space shuttle probably was not endangered by a sprite. I'm not sure I'd volunteer to be the first astronaut to fly through one either. We just didn't know for sure. It works out that if you had about 100 descents into Kennedy, on landing, over the Midwestern U.S., during summer nighttime periods, you'd have about one chance in that 100 of being involved in the envelope of a sprite.
3, 2, 1... and liftoff.
NASA took their chances on the 107th shuttle mission in January 2003. No extra shielding from the new forms of lightning had been installed. But the shuttle was to hunt for the giant bolts, alongside 200 other science experiments. The sprite hunt had been inspired by Yoav Yair, Israel's leading lightning researcher.
I came up with the idea of maybe doing some sprite research from space during the night part of the orbit. There were earlier tries to try and look for sprites from space. We had a superior instrument on board, so we figured out we can do a really good job in hunting those elusive sprites.
Yoav's friend, Israel's first astronaut, Ilan Ramon, was to film lightning from the shuttle.
This phenomena was new for the scientists, and they are trying to figure out what is all about. And our camera is actually the best way to monitor and try to catch these sprites going up to space.
The shuttle crew pursued giant lightning during 42 night orbits.
This is Mission Control Houston, pilot Willie McCool operating the MEDEX experiment, with one of its secondary observations being to look for the sprites or the lightning phenomena that are associated with the thunderclouds and the lower ionosphere or uppermost atmosphere of the Earth.
The crew filmed hours of video of giant storms like this. They followed lightning illuminating the clouds from below to pinpoint the area where sprites would explode above the clouds at the edge of space.
And Houston, we're back tracking good storms again.
Video of the first storms was beamed back to Mission Control. The final tapes were kept on board to be handed directly to Yoav Yair. But the handover from the most ambitious hunt yet for giant lightning was never to happen. At the end of its 16-day mission, the Space Shuttle Columbia was re-entering the Earth's atmosphere above the coast of California. On board were the films of storms from space that could help scientists understand giant lightning.
On the morning of February 1st, we were expecting the re-entry of the shuttle, watching the big screens and, just chatting away.
A crew member filmed the last moments inside the cockpit. Superheated air can be seen flickering across the porthole as it re-enters the atmosphere at 27,000 miles an hour. Cameras inside Mission Control at Houston recorded the last communications.
Everything looked good to you? Control and rates and everything is nominal, right?
The shuttle videotape cuts off abruptly.